All right, you are welcome back to our physics class. We have this question to solve. A millimeter of resistance 5 ohm and full-scale deflection of 50 milliampere is to be used to measure the potential difference of 50 volts. The resistance of the multiplier is dash. This question is from the topic current electricity, and the subtopic is from conversion of milliammeter to a voltmeter. You see, under electricity, we we tend to convert some instruments to another instrument after we must have carried out some modifications. And this is an example of such scenario. Here we have a millimeter. Before anything, so what when we talk about millimeter, what comes to your mind? Some students normally confuse millimeter with a galvanometer. A millimeter is an instrument that measures small amounts of current, while a galvanometer only detects the presence of current. So for galvanometer doesn't have calibrations. So just to detect whether current is present or not. But for millimeter is a calibrated instrument, so but it's used in detecting small amounts of current. So that is that. This millimeter now we want to use it, we want to modify it to perform the function of a voltmeter. So now when if we want to carry out such the modification you have to do is that you need to get a multiplier, a high resistance uh, multiplier, which will be connected in series with this device, that is the millimeter. So now the question on the board tells us that we should calculate the resistance of that multiplier that needs to be in series with this millimeter. This is a very cheap question. So let's see. Well, because before anything, so I will just use this diagram to explain. So before we go into the calculation, you can see the total potential difference that will be across the millimeter and the multiplier, and at the end of the day should be 50 volts. That is the one that you want to measure. So the 50 volts should now be the addition of the potential difference across the millimeter and that of the multiplier. So let's see. It means, so what I just said, let me represent it on the board. Vt is equal to your Va plus Vm. So you can see our Vt is 50. So for our Va now, you can calculate your Va using your normal Ohm's law. That's the Ia multiplied by Ra. That is the resistance across the millimeter. Our Va now, which will be Ia, this 50 millimeter we pass through this millimeter, and it's this the same amount that will pass through the multiplier. Don't forget the arrangement is in series. So and when we have series arrangement like that, the same current flows across. So then we have Ia, that is our 50 multiplied by 10 raised to power 3 because of uh, the milli that is there, multiplied by the current, that is 5. 5 multiplied by 5, so that would be 2. That's 250 multiplied by, so 1 over 1000. So you get 0 cancel 0, 1, 2. You move this from behind twice. So then you have 0.25 volts. So that is the potential difference that will be across the milliampere. Now you want to look for the resistance of this guy, this multiplier. So before that one, that means before you cannot calculate the resistance here without calculating the potential difference across the multiplier. So now this one also is very possible. How will you calculate the potential difference across the multiplier? So simply you come to this relation. Vt is equal to Va plus this. You have your Vt, which is so we have this relation Va for Vm. Our Vt now, that is 50, equal to Va. What's the potential difference across the milliameter, that is 0.25 plus Vm. Now I can get my Vm by subtracting 0.25 from 50, and if you do that very well, that's going to give you 49.75. So now we can still use our Ohm's law. Our Vm, remember, Vm is equal to Im multiplied by Rm, and the question says you should look for Rm. Your Rm will now be Vm over Im. What is your Vm now? My Vm is 49.75 over what is our Im? Our Im, that is the current here. So that is 0. That's 0.25, and then if you do that very well, you're going to get 995 ohms. Ladies and gentlemen, honorable viewers, I tell you, the resistance of this multiplier is going to be, that is Rm will be 995 ohms. So that is that, and then so you should know that it is a very high resistance, which is in line with what we said earlier on, that each time we are converting millimeter into a voltmeter, so you need to connect a high resistance multiplier in series with it. So thank you very much for watching.